All right, thank you everybody. Welcome and thank you for joining us for BIM for MEP Design and Detailing. My name is William Spear. I'm an MEP and Design to Fab SME, and a little bit about my background. I've been in the industry now for 25 years. Been on the consulting engineering design side, PM there. Did a lot of commercial industrial piping detailing. Worked for Autodesk as an MEP and Design to Fab SME for a number of years, and currently am consulting to the MEP manufacturing and distribution industries. And on the call with us today are Adrienne Finch, who's joining us. She is the industry marketing manager for Autodesk, and Kelsey Lemon, who is the technical marketing manager for Autodesk. Adrienne?
Thanks, William. So before we get started, I just wanted to launch a quick poll to get a better sense for who's joining us on the call today. So if you could please select an answer, you should see a box popping up on your screen now. Okay, I'm going to close the poll now. Great, so it looks like the majority of us are engineers and designers. And just as a quick reminder, there is a questions box in your GoToWebinar panel, so feel free to submit questions throughout William's presentation, and we will do our best to get all of your questions answered. Go ahead, William.
Okay, thanks, Adrienne. So we're going to look today at the MEP solutions that Autodesk provides, and no other company really provides a critical insight across industries that Autodesk does. And Autodesk solutions are used in almost every industry where anything is designed and made, from manufacturing to media and entertainment, mining, infrastructure, construction, you name it, and of course MEP design and fabrication. And the industries are all facing similar challenges, so they need similar capabilities. And what we're seeing is how things are designed and made all across Autodesk's industries is converging. So some of the more progressive construction companies are operating now more like manufacturers, and they're prefabricating and assembling things like modules, spools, assemblies, multi-trade racks, all the MEP services and so on. That's all being prefab now. There's a general shift to that because of the labor savings and just because it's generally more efficient. So at Autodesk, the expectation is to do more with less resources and to do it better. And why are we focused on this? Well, because more is inevitable. Right now, the global middle class is growing faster than any time in history, and roughly 400,000 people join the middle class every day. With this increasingly urban population also comes the demand, though, for more of almost every kind of resource: housing, technology, healthcare, new and repaired infrastructure, every type, and so on. But at the same time, there's the problem of less. There are less resources. So the more we make, the fewer resources we have left. So we're less limited on natural resources, less skilled labor to go around, which we're seeing a lot more of right now. And we waste a lot. If you think about it, the manufacturing industry, or the construction industry, excuse me, a total of 30% is waste in every construction project. It's pretty much a well-known number. So we have an incredible opportunity to do better, is the point. And we can do that with automation. For decades, automation has helped us offload tasks and optimize processes. And this new relationship with automation combines human innovation and computer automation, and it's helping people to imagine and realize new kinds of design ideas. So how does this all translate? What does this imply? Automation is changing the things we make and how we make them and how we work. So what about, whoops, sorry, I bumped the wrong button here. There we go. So with regard to things, whether products or buildings, they're becoming better suited to human needs, more customized, more configurable, more connected. Ultimately, they're just becoming more valuable to us. In the realm of making, robots are moving from the production line in factories to the construction site. So you've seen 3D printing, you've seen a lot of that. It's going on from prototyping to production quality. We're capable of making things increasingly complex and with higher fidelity using computer-aided design, literally computers physically aiding in the, not design, but the construction. And finally, the work is changing. So as the processes of design and making converge across industries, and industries themselves are converging, construction is becoming more automated. So it's becoming more like manufacturing. More things are being prefabricated. There's more modular components being built and so on. Teams and supply chains are increasingly connected now because of that. So automation gives us the opportunity to co-create with computers and to do more meaningful work. It's changing the way what we're capable of making. Autodesk solutions facilitate all that. If you look at it globally, just to put some truth behind all this, why this is really happening globally, we're doubling the number of city dwellers over the next 30 years. We're seeing around 200,000 people migrate to cities every day around the world. And in the meantime, the world will build an average of about 13,000 buildings per day between now and then. So 4 things actually impact our ability to satisfy that demand. It's going to be very difficult, if not impossible, for the industry to satisfy this need for growth without making technology investments to improve productivity. The challenge we're facing today is that the industry is not really set up for success in terms of production, collaboration, and efficiency. We're still working old-fashioned. There's still a lot of folks that are still on paper, still passing information along the old-fashioned way and losing fidelity along the way. We're typically operating in a fragmented way. So we're operating with low margins, and sometimes those are self-inflicted, high risk as well. The design and construction industries together could save an upwards of 1.2 trillion per year moving to fully digital processes. And that's if you look up the McKinney report, you'll see those numbers there. But let's take a look at how BIM adoption will enable you to solve these challenges moving forward. BIM is the solution to the industry's challenges, as well as the business challenges of MEP firms and contractors, because building information modeling is an intelligent way of designing and intelligent way of construction. It's using a 3D model-based process that equips architects, engineers, and construction professionals with insight and tools to more efficiently plan, design, construct, and manage buildings and infrastructure. So you can even take BIM into 7D, where you start managing the project and feeding I'm trying to think of the right word for it, but feeding the solutions for building management, ABS solutions, automated building, something like that. I have to think of the word. Anyways, what BIM affords effectively is you can improve project understanding and increase decision making, the ability to make decisions with intelligence. You can share and use the same consistent data across the project life cycle. You can do that both from your desk or in the field. And everyone can respond quickly to changes using processes that are smarter and that are faster. So the path we're on is connected BIM, and connected BIM is what we term as the power of the cloud. It's a cloud-enabled, intelligent, model-based process. It unites the design, the build, and the operating segments together. So connected BIM really just equals BIM plus the power of the cloud. It gives you real-time collaboration, and doing so with up-to-date and current information. So thanks to BIM, what we're seeing is some really incredible changes in the MEP industry and a number of trends that are tightly connected to how teams are using technology. So some of these include owners realizing that the benefits of BIM and the associated project savings, and they are the ones driving us to more BIM mandates and the advancement of new standards supporting BIM maturity, like National BIM Standard and LOD requirements across the world. There's also been an explosion of data that's been produced by the BIM projects with higher fidelity and greater frequency, a lot more than we saw with 2D in the 2D world. And that's especially increased now with computational power that we have today. And all of that explosion of data is actually easing the way to what's next, which is AI, artificial intelligence, which is starting to take over. As I mentioned earlier, more and more robots are being used. Well, the AI is not just used for robots, it's also used for things like ensuring that your bill of materials is complete. So if that explosion of data is standardized and good, you actually are greasing the wheels for the implementation of AI, because AI requires a lot of data. The third thing is the ability to collaborate across distances. So right now, teams are assembled across different offices and even different geos, representing large talent pools. And some global companies are actually working around the clock. They're passing a project around the clock using 3 8-hour shifts where one hands off to the next. In order to do that, you have to be really standardized, and the flow of information has to be solid. So what it's causing, and what you're seeing here in this slide, is it's causing engineers to extend their services downstream, and fabricators and installers are extending their services upstream. What I mean by that is engineers, for instance, can now offer O&M services. Engineering firms that never did that before can offer to operate and maintain the building as one of their services, because if you think about it, who knows the building better than they? They were the ones that designed it. Likewise, fabricators and installers, well, they too could actually offer their services to the O&M world, but think about it, a lot of those companies now are getting more and more into design assist, where they're helping the designers on the design end build something that's more constructible for them, so there's less rework when the time comes for that job to go into construction mode. So this is what we're seeing because the technology is allowing this to happen. Stakeholders are relying more and more on data to communicate. All right, so I think what you could say is this in turn kind of creates a unique set of business challenges. The challenges that they're finding result from disconnected workflows, and that's because you have disparate software tools being used by project stakeholders, and you have siloed teams that are disconnected, workflows internally that within firms that result in costly duplication of effort and increased time. We see it all over the place. Professionals with unique skill sets can't engage early or influence early, which is something that's huge. If you can get everybody on the same page and working together as a team, then when decisions are made early on, somebody else with a professional knowledge of X says, hey, wait a minute, we can't do that because blank. And it's that kind of participation that we're looking to foment. We want to really increase that. So without that, you're adding risk to securing procurement paths and so on. One of the other biggest problems we have is fast-track project schedules. It's hard to achieve. The challenges of managing and coordinating materials and labor, and the miscommunication of design intent increases exponentially. And of course, one of the other ones that we're seeing, especially in the construction sector, is waning skilled labor pool. That makes it difficult to hire and retain talent and inhibits the adoption of new technology. So what are some of the benefits of BIM for MEP? Autodesk's MEP portfolio, the AEC collection, allows you to overcome some of these business challenges by connecting the design to detailing, fabrication, and to the field for installation and construction. And they're doing that with software solutions that work together. So we talked about collaborative BIM. That's where we're using the cloud to keep things connected together. That allows you to meet the BIM requirements that owners are mandating now. They're becoming increasingly common across the globe, and it allows you to collaborate more effectively with other stakeholders on the project by using that common model authoring tool or platform in the cloud. So what are some of the different products in the solution? The portfolio of technology supports end-to-end workflows across the building life cycle. So all the way from concept to design to detail, through to fabrication and install, and even to O&M. For MEP professionals, Autodesk provides a number of interoperable tools to help you move from design through fabrication and installation. And a lot of those are accessible through Autodesk Architecture, Engineering, and Construction Collection. Additional products enhance the collection by providing powerful detailing and fabrication and analysis and collaboration capabilities for building systems. And finally, that their cloud-based collaboration tools means you can put projects at the center of the design team, providing team members access with the most up-to-date project data whenever they need it, and connect to the office and to the field. So there you can see, just in the conceptual stages, how you can start off with BIM. You can carry all this data downstream. We can start with just simple masses and put information or metadata into those masses that allow us as MEP designers to determine loads on the building, to get some basic understanding of what the sizing of our equipment is going to need to be for electrical loads, for BTUs, for tons of cooling, you name it. We're going to be able to get at least a basic understanding if we take the time to do it. And it doesn't take much time to create some masses and or leverage what the architect has done early on. So some of the things you can do is create MEP intelligent 3D design models. You can use reality capture technology to capture existing conditions with accuracy. You can design for performance using the analysis tools early on, and we're going to talk a lot about analysis here in a few minutes. Improve decision making by exploring parametric conceptual design options, and optimize the design of your building systems, and do that while automating tasks and design workflows to improve productivity. So what is at the foundation of all this? The foundation of all this is Revit. Revit is the foundational Autodesk BIM workflow for MEP engineers and contractors. And what it does is it allows you to streamline your projects from design to fabrication to installation, and everything starts with and connects back to Revit. So you can predict the loads and system sizes I mentioned, and then accurately design, model, and document building systems. You can coordinate with other stakeholders to support integrated multidiscipline design. You can do everything from energy analysis to interference detection, and extend the design model for detailing, fabrication, and installation. So what you end up with effectively is a digital prototype. And that's what Revit provides. That's the most important thing Revit does. It gives you the one place where you can actually build a real building with real systems and do it all without ever sticking a shovel in the ground, because you've done it digitally. And what that also provides, we found this to be the case more and more now, is it provides a single source of truth. That single source of truth means simply that if you do everything in the model, whenever there's a question, everybody goes back to the model. So whenever there's a model at play, and if any of you have already been into Revit and used it, you'll know that whoever has the model is where everyone goes back to see what is the source of truth, what is the answer to our question. So that is the real value of Revit. Revit is the foundational model base for whatever it is we're going to do on a project. So we can leverage that for analysis and so on, but we have to start with a model. So how do you capture some existing condition? Let's say you want to start on a project that's a remodel, let's say, and you need to go and capture some existing conditions. Well, you're going to do that with laser scanning, which has become pretty much ubiquitous now. You can use BIM for a retrofit project, and allows you to design with greater precision using scanning, helping to avoid issues that may arise that you would normally see with 2D design files. It also spreads the design and documentation process and allows you to provide a more accurate model of as-built conditions to the project owner for use in operation and maintenance if you want to. When you think about scanning, think about how long it took to do this with a tape measure and documentation. How long does that take? Anybody that's ever done that knows the difference between that and scanning. So what do we use for scanning? Well, I'm glad you asked. For scanning, Autodesk has Recap, and Recap is a powerful and easy to use solution for reality capture, and really what we call it is a scan to BIM workflow. Autodesk partnered with a number of hardware vendors, including UAV and drone manufacturers and laser scanning manufacturers, and Recap Pro has been designed for use by someone with no previous experience. So it's very user-friendly, in other words. One-click automated workflows do powerful tasks like scan registration or stitching. You can stitch multiple scans together into one point cloud. You can use intelligent cleanup, which automatically removes unwanted noise. You can also use capture technology to track your daily progress on a project. You know, how much work is being done, and use that to stay on schedule and get an understanding of how much has been installed in the field that day. But most importantly, perhaps, I think Recap integrates with all of Autodesk's key AEC design creation tools, including Revit. So here's how Recap and Revit work together. With Recap, you can create scan to BIM workflows, meaning you can create elevations, floor plans, 3D models, all from scan data directly in Revit. So Recap loads into Revit. You can do that from the Revit interface. And once the scanning process has been completed, you can define regions in Recap that we can use to define level heights and elevations in Revit. And just as scan data can be used as a reference point to create floor plans like you're seeing here, MEP stakeholders can use the same intelligent Revit modeling tools to define system elements such as piping, ductwork, conduit, equipment, and so on, complete with accurate dimensions. And then afterwards, you can make new additions to your Revit model for retrofit renovation purposes. But for the MEP side of things, there are additional tools that tie into Revit and into the scan where you can take those scans and actually identify systems with it, like piping systems, duct systems, and so on. So there's some aftermarket products that really do a good job of that. One of the other things we want to talk about is designing for performance. Autodesk BIM tools make it easier than ever to optimize building performance factors like ventilation, the effectiveness of stack ventilation or natural ventilation effectiveness, air quality, thermal comfort, and do all that at the earliest stages of design. So Autodesk powerful energy analysis tools use DO2 and Energy Plus simulation engines, and they use that for the whole building analysis. You can use it for peak heating and cooling as well, energy performance, daylighting, solar radiation, and all that allows the designer to monitor performance changes throughout the course of the project. So anytime any changes are made in the project, you can rerun that analysis. So Revit includes direct access. When you purchase Revit, you have direct access to building performance analysis using Autodesk Insight, and that is the tool that we've been talking about. With push of a button, you can send your Revit model to the cloud for analysis, and it gives you the ability to test varying geometries or various geolocations for the same high-performance design, let's say. Results come back pretty quickly in a visual, easy-to-read format, making it easy to identify opportunities and to improve your design. You can even see how the data was calculated and have full confidence in your design, but most importantly, with Insight, you're now able to provide guidance. And what I mean by that is, you remember how you used to get a wall of information if you ever ran analysis? Well, that wall of information is still there underneath, but it's presented in a way that's meant to share analysis results with the owner or with other project stakeholders, whoever, but it does it in a way that how design options impact are easily understood by all and meaningful to all. So there's no need now, what's really cool is there's no need now to create a separate energy model for that, like we used to have to create a clean energy model. So let's take a look at how Insight actually works here. Hang on a second, let me get my play button there. When you go to Insight, this is what Insight looks like. It's cloud, or it's web-based, so for starters. But when you go to create an Insight model, you simply export it out to Insight, and then Insight runs the analysis for you. And what it does is it takes the information from the Revit model, and again, you don't have to create a new clean Revit model. It's a smarter analysis tool now, so even if there's gaps in walls and those kinds of things, it understands that the space doesn't go to infinity. And it provides the data return, as you can see here, it's colored. So the colored data returns tells you whether or not it's below ASHRAE 90.1 standard or meets it, or if it actually achieves the architectural 2030 standard, carbon neutral 2030 standard. So right there you can see red, orange, and green. And it provides these widgets, and the widgets give you immediately information on how well this building is performing. So on the left we can see it's in the red, so we know it's not performing as well as we want. And the building orientation here on the right, you can see that there's a graph that shows you what changes make, how much that impacts. The steeper the graph, the more impact, the more ROI. The shallower the graph, the less. And where you see the little triangle, that's where the building is that we put into the analysis. What's cool about this is when you run the analysis now, Insight runs the whole range of possibilities for every element. What's the whole range of orientation? What's the whole range of window glazing, of all the different elements? It runs the entire range for you. So as long as the model stays relatively the same, you can test different scenarios without running new analysis, right? This is huge. This basically is giving you a mean result, right? And you can open any of these widgets and change values in them if you want, and see how immediately it tells you how it affects all the other values of the project, of the model. So slide it around a little bit and you can see right away, okay, we're getting closer now. So now we're at least meeting ASHRAE 90.1 standard. But generally speaking, this gives you information that's meaningful, right? It's not that wall of information that you used to see all the time. You can share this with other stakeholders. And there's plenty of resources online, and I strongly suggest you take a look at this, because analysis now, today, versus 10 years ago is like day and night. It's a lot easier to use. It's all using ASHRAE, all using DO2. It passes ASHRAE 140 standard, so everything in here is standardized. It's industry standard. I think it's SMOT standard for model testing. But all that is covered. In other words, it's very thorough, but just as easy to use, not like it used to be. So anyways, if you haven't taken a look at Insight, I strongly suggest you take a look at it. All right, so we've talked a little bit about data capture and analysis. Let's talk a little bit about automating design tasks and how you optimize that. Generative design tools are becoming increasingly popular among MEP engineering community. Using those tools, designers can optimize building systems designed by exploring design options easier. Automating repetitive tasks is another big help. That enables designers to design complex systems faster, and it improves design accuracy as well. What are we talking about? We're talking about Dynamo. So Autodesk Dynamo Studio helps MEP engineers leverage the benefits of computational design all through a visual logic environment. In other words, it's on-screen programming. So there's no programming required, really. It's just logic connections. You can work with Dynamo either in Revit itself, or you can do it untethered from Revit using Dynamo Studio. So you can work inside or outside of Revit. And Dynamo's interoperability with other tools allows for maximum flexibility. You can implement that into your BIM workflow. You can use Dynamo's open source community to share your scripts and try other people's scripts. Just to give you an idea, I went and took a look just to see what other people were saying and what they were doing. Here's some incredibly cool ways to use Dynamo, and this is just the tip of the iceberg. I strongly encourage you to go online and look and see what other people are doing. But if you have Autodesk or Revit provides links between rooms and spaces, you can actually make those a lot more accurate and efficient. You can link between Excel and spaces to drive loads. You can link between the diffusers and the main duct early in design. So without even connecting anything, you can summarize terminal loads, distribute specific airflows or specified airflows across actual terminals. You can create a highlight check. So you can do that for diffusers that exceed max flow. What about aligning base of pipe for multiple pipes? You do that with Dynamo. You create a multi-pipe support, array those supports, and output the BOM. These are real things people are doing with it. Predicting wall openings for MEP services I thought was cool. Then they take that and extract the wall sections for construction. And another one I saw was linking space parameters to family parameters. So a family reports its location. So these are some neat things you can do. To actually see how this works, and so you can see this in action. This is, who was this? I'm trying to remember who it was. Oh, Horley, that was right. This is Horley, and what they're using Dynamo here for is to show or to distribute heat loads across terminal devices. In this case, they're doing this for radiators. But this gives you an idea of how Dynamo looks and feels being already in Revit. And again, like I said, you can take Dynamo out on its own untethered in Dynamo Studio. But at the end of the day, what I cannot recommend more strongly encourage you, there's a huge online user base out there, and they're sharing their ideas and they're sharing their scripts. Strongly suggest you go out and take a look at that, because what it'll do at least is it'll spark some ideas for things that you find nearly impossible to do and make those a lot easier. You didn't realize there was a solution for that. All right. So we've taken a look at the conceptual side of things. Let's talk about actual designing. During the design phase, you can use Revit to model to a very high level of detail. So that allows you to solve design challenges through rapid iteration with computational design tools, and you can automate tedious tasks. You can use Insight analysis to optimize designs, design performance. You can leverage Navisworks to improve design model coordination and prevent clashes. Basically, you're improving multidiscipline design collaboration, and you're doing that with cloud-based design tools now that provide instant access to all stakeholders to the most up-to-date BIM data anytime and from anywhere. So improving design coordination allows you to better control project outcomes, minimize delays and rework, and so on. It basically extends the project team by using tools like Navisworks. So in this case, Navisworks Manage, we're going to look at. Navisworks allows you to aggregate design and construction files from numerous formats into a single holistic model for project review, helping you to resolve clashes and errors from the time before construction even begins through to project completion. So this is Navisworks. Navisworks Managed. Again, the features of it are clash detection, interference detection, aggregating models. And in fact, another part of this I forgot to mention was timelining the project as well. So what does Navisworks look like? This is running. So here we're taking a look at Navisworks. We're going to look at a couple of innovative ways to use Navisworks for clash detection. So everybody knows about clash detection, but how can you use that innovatively? What can you do that's different, right? Something that most people may not even think about. So when you're ready with your file, you simply export it out as an NWC file from Revit and import that to Navisworks. What we're going to do here is we're going to run a couple of clashes. You can see on the left I've got composite parts here. Those composite parts are simply clearance geometry that I modeled onto equipment. And clearance geometry means something like door swings on access panels. It could be 3 feet clear in front of a power panel. It could be the clearance above power panels for piping and so on. Basically anything that would normally pass clash detection that shouldn't, because if you open the door swing, you can see it would swing into pipes, right? So you couldn't get the door open. How do you find those clashes? You model clash geometry. And here what I'm doing is checking it against pipe accessories, pipe fittings, and so on. And as I click on each of these clashes, you can see that it takes you right to that particular element in the model. So there you have it in Navisworks. You can see where these pipes are actually just barely touching the door swing area there. So another cool use for this would be, what if I compared ducts and duct fittings to rated walls, 1 hour and 2 hour walls? Why would I do that? Well, I'm glad you asked. That's a really good question. The reason you do that is simply because wherever you have a rated wall and a duct, what do you need there? You need either a fire damper or certainly smoke damper, but you need a fire damper there, right? So if you run this clash, you're not looking for things that actually clash, but you're looking for places where you can make sure that you have fire dampers in place. If you use the switchback tool, you see that right away it takes you right back to Revit, and inside the Revit model I can then go back and make sure, is there a fire damper here, right? So those are a couple of ways that you can use Navisworks that maybe people don't talk about all the time, but my point in bringing them up is, what are some other ways you can think of that you could use Navisworks for clash detection for things that people don't normally use it for, right? Maybe that gave you some ideas, hopefully so. Okay, when it comes to streamlining project delivery, there are some overarching technologies that synchronize these solutions. And that for Autodesk is cloud-based collaboration tools. And those allow design teams to work in new ways. So what you're doing is you're centralizing project data in the cloud. And that way firms can accelerate design delivery by enabling teams in multiple offices, like we talked about, across the globe, even in different continents, to concurrently work and share models. And I actually work with some companies that are doing that right now. So in addition, this technology makes it easier, of course, for MEP firms to work fluidly on design build, design assist, and IPD projects. Okay, so what are these tools? Well, when we see the words Autodesk BIM 360, BIM 360 means Autodesk Cloud, right? And we're going to talk a little bit about Autodesk Design, BIM 360 Design, which now has BIM 360 docs built into it. So the solution for design collaboration is BIM 360 Design. It's a cloud work sharing, design collaboration, and data management product for project delivery. And it's built on the new BIM 360 cloud platform made for distributed multidisciplinary teams. So they can co-author Revit models with greater file and folder-based access control, issue management, deliverable coordination, change visualization, and it gives you unlimited storage as well. It really basically includes 3 key elements. You have controlled cloud work sharing in Revit, or what used to be the product we called collaboration in Revit. You have document management module on the BIM 360 platform, and then design collaboration module. So what started off as Revit Server for some of you that go way back and then became collaboration for Revit has now evolved to become the BIM 360 portfolio of cloud-based solutions. So this is Autodesk's premier cloud-based multi-user design tool for Revit. Again, BIM 360 allows multiple users in any location simultaneously to author in a Revit project. That way you can all be in the same project at the same time without stepping on each other, you know, sharing or checking out work sets and that kind of thing. And on top of that, you can invite anyone to the project, even just to view it. You simply provide them a link, send out an invitation. It provides them with a link and a password. and they're in the project and can see what you're doing as well. So if you want somebody to be able to see it without authoring, you can do that also. Okay, I'm going to speed that up. All right. So we've gotten through the conceptual side, the design side, and now we're going to look a little bit into detailing. And getting into the detail phase, contractors now can quickly and easily access, or sorry, excuse me, can quickly and easily create BIM-based detailed models in Revit. About 3-4 years ago, I believe it was, if I remember correctly, Revit became ITM portable. ITM is detail level content file format. So not just families now, you can load ITM content into Revit. That allows you to easily create detailed shop drawings from the design intent model. And you can do that directly in Revit, or you can use Fabrication CAD MEP to prefabricate the systems from it. It allows you pretty free workflow back and forth between the two, either embedded in Revit directly or going out to CAD MEP. The things include, the design elements that you can do include duct assemblies, pipe and conduit spools, and so on. You can more accurately identify and resolve major coordination issues with architects and structural engineers and other designers and other industries, I should say, or disciplines before the detailed design begins. Because once you start getting to a detailed level, of course, now you're adding flanges to duct work, and things that normally might be overlooked are now there in the detail, in that level of detail. The ITM elements you may have heard in Revit are called fab parts, and really allows you to perform value engineering tasks more efficiently. You can leverage real world ITM content. Take a look at this here. Basically, this is what the design looks like now. When you take a regular Revit design, of course, that duct in the back would be one long segment each time. Here, they're actually built to SMACNA standards. You're extending the Revit design model now to an LOD 400 level. In addition, contractors can create detailed fab shop spools from this. They can do piping spools. Models basically are ready for shop drawing and procurement, ductwork manufacture and installation. And for ductwork, it's shop standards, and for piping, it's manufacturer-specific piping. So over on the right side, you can see where some of the MEP fab parts are listed there. You have the library on the right. So whatever ITM library you load into, Revit can now read that. Okay, that's Fabrication CAD MEP. Again, it's kind of like Dynamo. You can do a lot directly in Revit now, or you can take the model out, export it out to CAD MEP and work there. This is a look at how Revit enables contractors to create the LOD 400 models, and this is ready for fabrication. So you can see that the hangers are placed as soon as you export the model in Revit, or convert the model in Revit, I should say, to fabrication level. There are some specs in there that allow you to place hangers automatically. Makes things really pretty easy, because once you have those hangers placed, you don't have to place them all manually. You can just relocate them if they're not in the right point. But something as simple or as tedious as hanger placement, there are rules in the specs that say I need to place a hanger before and after each coupling for drain, waste, and vent pipe. Here you can see how, if I want to actually do some design work or need to redesign, let's say the model I got from the engineer wasn't where it needed to be, I need to redo some things, I can do that actually in the fabrication level detail. I don't have to do it in Revit's more generic format. I can do it directly with those parts and pieces that I've assigned that I know are needed for that particular pressure class or whatever, what have you. But the long and the short of it is, now that you're building things in the shop that go out to the field, they're going to be right the first time. We even saw firms that weren't using this before and afterwards found that when things were going out to the field, they were cutting them back up in the field and re-welding them and redoing what they had to do out there because they weren't made right the first time. That all went away when they switched to the workflow with CAD MEP and then with Revit portability as well. It made it even easier to do that sooner. So Just to give you an idea, just an example, I've talked to a lot of companies out there. One of the companies that we have some stats on are from AG Coombs, and other contractors all report the same thing. The more prefab they do, the better the labor rates, the fewer the mistakes, less waste, less time. I know one company had their recycle guy came in and got upset with him because he said, look, if you want to go with another recycler, I'm fine with that. Just let me know. You know, you can give a guy a heads up. So they didn't know what you're talking about. What do you mean? He said, well, your dumpster out back is nearly empty. And all of a sudden it hit them. They realized, wait a minute, we've changed our workflow. We're actually using prefab. We're doing a lot of prefab work now. Holy smokes, our recycle has gone down. So there's some value added benefits that people don't even realize until it hits them in the face. Another great story to look up is Miami Valley Hospital. So any of you want to Google that after the webcast. That's a very well documented ROI for prefab and modular prefab. They give all the stats in there on production levels, how they increased, efficiencies, safety, all that stuff. There's a number of things. I mean, just think about safety for prefab. If I'm building a rack on a bench, I don't have 100 trips up and down a ladder. I'm building it on the bench where I can test it and all that. When it goes out to the field, that rack goes up in the ceiling, or if it's buried, it goes down in a trench, and I'm in and out in a few minutes. So there's so much value to this. And here are some of the numbers. You can see 0 duct wastage through connected workflow, 1% cost savings assisted by prefab, and then 0 clashes in the field. All right, so we've looked at conceptual, design, and detail, and now we're going to go to fabricate and install. And besides just providing powerful tools to help contractors to drive workshop processes to satisfy manufacturing requirements and more efficiently fabricate sheet metal and piping, you can leverage the broad portfolio of collaboration and coordination tools to improve field installation and speed project delivery. So if you want to bring model accuracy to the field, look at how you can eliminate traditional measuring methods like tape measure to lay out points. You can use point data directly from the model to drive field layout with robotic instruments. So initially I talked about Autodesk having partnered with a number of different other firms for scanning. The same thing goes from data that went for data collection applies to this, which is point layout. So you're collecting data with a scanner, and now you're laying out that data using a laser as well. So Autodesk has partnered with a number of folks for layout as well. It allows you to import staked points back into the original model if you want to go the other direction, but you can also take model points and lay them out in the field. And we're talking about is point layout here. So this allows you to improve office to field efficiencies, and QA/QC reduces work and supports field layout during construction. It integrates, point layout integrates with Revit to connect design, detailing and fabrication, and installation. You basically eliminate drawings in the field to speed up and streamline installation, and you improve accuracy, which saves you time and money. So take a look here at how Revit point layout works. This is it in action. So if you have point layout installed, you can see there's a point layout tab, and you create the hanger points, take those out of the model. We'll select all of them here. And then once those have been captured, we can see what we have listed, what did it collect, right? Each one has a unique point number, and then you just click on zoom and it'll take you to that exact location. So each one of these tells you where you're at. And these points are points that you embed in the model. So you can actually embed them in the families, or you can add points if you need to later, specific points. And then before you export them, you can see that you can use XYZ, northing and easting, MEP layout. You can use scene targets. You can export it out as a CSV file. And most any layout total station will accept a CSV file. And then you can send that out. And there you have a CSV file that comes out. That's what your CSV file looks like. All right, so we've seen a number of Autodesk BIM tools and workflows today, and they're all part of the broader portfolio for MEP. And as you've seen and heard, Autodesk has a great breadth and depth of BIM solutions, and these tools are designed to work together fluidly to give you seamless and connected workflow. And if you take a look for a minute at this chart, you can see that Revit, which I said was that main tool that's the underpinnings for all of this, is usable throughout, from conceptual design where you can create masses through the design phase and even detailing now, and of course fabrication and installation, right? So we've seen all that work all the way through. The other two tools that work across the entire spectrum are, of course, BIM 360 Design with BIM 360 Docs built into that. So no matter where you are, whether it's a conceptual stage or you're fabricating and installing, you can use the cloud to keep everybody connected together. And just to recap this, pardon the pun, you can use Autodesk Recap, Insight, and AutoCAD and Dynamo Studio, even from the conceptual stages. And I would continue using Insight throughout because you want to double check and make sure that the analysis hasn't changed based on some model change. And now it's very simple to go and rerun the analysis, simply send out another analysis. As a side note too, every time, in case anybody's wondering, every time I send the model out to be analyzed, send it out to Insight, there's no cost for that, right? That's a free service. There's no cloud credits used to do that. The only cloud credits associated with that is if you ask for a rendering with that. There's a feature in Insight, one of the features in Insight, where you can actually get a rendered view of what the heat map looks like or what have you. That would cost, but otherwise running the standard analysis doesn't cost anything. So use it a lot, get familiar with it. Once you get to the design phase, of course, you're going to start using Navisworks Manage. There's Fabrication CAD MEP Fabrication CAD MEP for detailing, and then at the end, obviously, you can use Glue and Build, which are part of BIM 360 Design and Autodesk Point Layout. The products that you see here are a solution offering called the AEC Collection. This is what makes up the AEC Collection, and really it's there to provide specifically for MEP engineers, designers, and contractors to give them a comprehensive package of all interoperable software and cloud services tools. And like you see, they support every phase of the design, detailing, fabrication, and installation. So using this collection, we hope firms can transition to BIM at their own pace by providing Autodesk Revit, BIM-based software for design and documentation, as well as AutoCAD and AutoCAD vertical products. So that pretty much concludes the presentation from my end, at least for the presentation portion of it. At this point, I'm going to hand it off to you, Adrian. You want to take it from there?
Yeah, that would be great if you don't mind advancing the slide.
Okay.
And you can just click through 3 times to build. So as William said, the AEC Collection is a comprehensive package of tools for CAD and BIM workflows. This includes our flagship products like Revit and Navisworks and AutoCAD Verticals, and other supporting BIM technology. So with the collection, you get access to a full set of software that really supports all of your project needs. And we make it available to you so that you can customize your tool set based upon you and your firm's unique needs. And there are a couple other benefits that come with the AEC Collection and a subscription to Autodesk software in general. So greater value, so you get an essential kit of software and services at a really competitive price, more flexibility, both single user and multi-user, and multiple term lengths to fit your business needs. And lastly, you have one collection for the AEC industry that provides a wide range of the technology that you need at any time, no matter the project. Next slide, please. And so what I'd like to do next is I'd like to launch another polling question to get a better sense to see if you're interested in learning more about any of the questions or any of the products rather that William went over today. So if you wouldn't mind filling in that poll, that would be great. Great, so I'm going to close the poll now. Looks like Revit and Dynamo are the winners here. And then lastly, I'd like to know if you're interested in speaking to to an Autodesk sales rep about any of the products, go ahead and answer here, and then we'll be sure to follow up with you based upon your level of interest. Okay, so I'm going to go ahead and close the poll. Great. Okay, next slide, please, William. Great. So what's next? So if you'd like to get more information on the AEC collection, you can simply go and review our overview page. Even if you just Google AEC collection, that'll come right up for you. You can also view our upcoming webinars. We're planning for another MEP webinar in March, so stay tuned for that. And lastly, check out our Revit blog. We post a lot of great content there spanning AE and C. So be sure to check out the blog. We update that quite frequently. And we also just posted some really great blog posts about our new Revit release. So go ahead and visit the blog. And next slide, please. Now I'd like to open it up to Q&A. So if you have any questions, please feel free to type those in the questions box. I see we have a few here, so we have about 7 minutes to go. Let's try to get through as many as we can. So William and Kelsey, are the recap files are quite large. Don't they slow down Revit?
Yes, so great question, and I'm happy to say that Revit has been optimized to perform better with point clouds. As a matter of fact, there is a link that I'm going to be sending out in a moment that talks about some of the best practices. So be looking for that link here in just a moment where you can get step-by-step instructions on how you can improve the performance in terms of Revit working with the point clouds.
Great.
You hear me?
Yep, we can hear you.
Okay, it looked like I'm muted. Sorry, I was going to answer that, but yep, that's fine. And by the way, I'll add as a side note, most everybody has digital drives now, or solid state drives. If you don't, that's a key. If it's running slow, anytime you're dealing with scans, make sure you're on solid state drives.
Great. And I see a lot of questions coming in about a recording of the presentation. We will be sending out a recording later today of the presentation. So you'll be able to watch that in its full entirety if you missed any of it. The next question here. I see the benefits of Revit and the model during design and construction. What are some of the benefits of Revit and keeping the model updated after construction?
Okay, that's a very good question. So going back to the point I made about a single source of truth, the word I was trying to, or the acronym I was trying to think of during the presentation was BAS, Building Automation Systems. There's several different kinds of names for those things, EMCS, Energy Management and Control Systems. So that Revit model can be repurposed as a single source of truth or as the foundation for, I suppose, what's the word I'm looking for? Filling in the data for those systems. So when you want to apply a BAS or an EMCS system to a building you just built, where are you going to get a lot of metadata for that software, for that solution? You're going to get it from the Revit file. So air handler numbers and lighting equipment and so on. And the more granular the information about those pieces of equipment, the more easy it will be when the time comes to operate and maintain that building to find where something may have failed, to go online and find easily just with a click of the eye, go click the object that's highlighted in the BAS, and it says it's located here. Here's the URL for the replacement for that piece. And as long as the manufacturer is doing their job, let's say that piece has been discontinued, the link that it takes you to will say, here's a link to the new piece of equipment that we're now using to replace that since the old one's been discontinued. So I don't know if that helps you understand where you can use that, but that's a great question. The word I was looking for is in the Revit model will inform the BAS system with the basic information it needs about the building.
Great, thanks for that answer. Here's one. Is BIM 360 in the AEC collection? And I can answer that. No, BIM 360 is not included in the AEC collection at this time. But there are a lot of other great tools in there, which I'm sure you can go and explore. Let's see. Is there Autodesk programs for school? So I'm wondering if this is about Autodesk software being available for students.
Well, it's one of two things. It's either that, which there is. So you can go to, I think, is it students.autodesk.com still? I think that's it. If not, it'll redirect you, but you can go there. And if you are a student and you verify you're indeed a student, then you can have free access to the software. The other possibility that they're asking here is, where is there schooling online or resources to learn more about it? And just in case you're asking that, the Autodesk Knowledge Network is an incredibly powerful resource online. And there's plenty of people there online you can connect with as well. But I would suggest starting there. Am I missing anything? You think of another online learning resource?
No, I'd say the Knowledge Network is probably the best place to go. Revit Forum as well. It's always a good one to visit. Another question here. What kind of jobs are there for whole Autodesk certifications?
Oh, man. There, when you're talking about AEC, architectural, engineering, and construction, pretty much anything you want is available to you if you have a knowledge of Revit, if you have a working knowledge of Navisworks. Those are a couple of big ones. And then, of course, if you know anything about fabrication and detailing, you'd be immensely valuable to any subcontractors and even sometimes GCs. So subcontracting, electrical, mechanical, plumbing, piping, hydronics, architectural, engineering, any of those realms, any of the Autodesk products you can use for that, they love you for it.
Great. And then one last question here. I work for a utility that is only now moving to BIM. Should we be moving away from sheet sets? And during this transition, should we create drawing packages in Revit or AutoCAD?
Okay, so sheet sets is an AutoCAD question. So the sheet sets doesn't really pertain to Revit necessarily. Inside of Revit, you have views where you can create sheets there. But sheet sets, I understand what you're asking. If you're going to stay in AutoCAD, in an AutoCAD-based environment, there's nothing wrong with sticking with sheet sets. They really work well. But to answer your question, if it was me, if I had to take off my cap today and put on your cap tomorrow and do what you're doing and decide we're going to go head into BIM, I would probably do it, because really what Revit is at its basic is it's a database. So just like in Excel, you make up a bunch of numbers as an analyst, financial analyst, and you hit a button and you get a pie chart, and all that information is exactly accurate. That's what Revit is, only now we're talking about length, width, and height for a wall that appears as a rectangle in plan or as a cube in 3D view. But everything that you see in all those views is actually one piece of data. So everything is accurate. That changes your entire business, because now you're dealing with not having to update sheets in Revit or in AutoCAD and that kind of thing. There's no disconnected information, I guess is the best way to put it. So it changes your business overall, which means I would make the switch to BIM. But here's the key consideration you have to take. When I go to switch to BIM, I have to make sure that the content that I need to do that is there. So as you're getting ready to switch to BIM, I would look talking to a reseller or somebody that can help you with content development to make sure you have the content you need to make that switch. I don't know what utility we're talking about here, whether it's electrical or if it's gas utilities or what we may be talking about. But regardless, you're going to need content to make it work. So focus on the content first. You can even contact us. You can contact me if you'd like to. Leave your email address in there if you want to further this discussion. I can talk to you about how to tackle that. But content is key to embarking on BIM.
Great. Thanks so much, William, for a great presentation and for taking the time to answer all those questions. With that, I'd like to pass it back over to Dina to close us out.
Thank you for today's presentation. Once again, the recording will be sent out to everyone who has registered via email. This will conclude our webinar today. Thank you for joining.